y equals 3 over x log x, ln x. So let's have a go at this one. Let's draw these constituent parts first of all then. The ln x function is only defined for positive x, and log of 1 is 0. So here's 1, and basically it's the e to the x curve but flipped in with the x and y axes essentially swapped around, because one is the inverse of the other. So we're drawing the inverse function with the x and the y axis sort of swapped around. So there's log x, ln x, and then 3 over x, well that's just characteristically speaking that's the same as the 1 over x curve, so that's going to come down from infinity just above 0, isn't it? And as x gets large, it's going to tend to 0. And on the negative side, it's going to come from 0 on the large negatives, and then start coming up here, and it's going to turn up to go to large negatives here on the other side. So that's what we've got then. But we don't need to worry about the negative anyway, so we can forget about all that. Didn't really need to even sketch it, to be honest. So this is what we've got. We've got up to here where they're equal one another, when they intersect. Oh, from one above they're both positive, and from one below rather they're negative and positive. So when we get 1, it's 0. So let's put that in the actual graph. 0, when x is 1, log of 1 is 0 times 3 is 0. So there's the point there. Now this product is negative, and we've got a large and a large, so clearly it's going to shoot down to infinity here. Now it's going to come around. Now this tends to 0 much, and this tends to flatten out. So if you put in 100, 1 over 100 times log of 100, you're going to get a very small number. So it is going to die back down to here, isn't it? So it's going to come up, presumably, turn around a maximum, and then shoot back down to minus infinity. So that's what we think is going to happen. So let's just put that in terms of what we think is going to happen. It's going to come round. It's going to turn back on itself, probably quicker than what I've drawn it, and then tend toward 0. That's not very well drawn there, is it? So let's just do that a little bit again. So it's going to just turn and then go back down. It's probably going to go up and down more quickly than a bit more exaggerated than the way I've drawn it here. Okay, that's good. So what have we got then? So we need a maximum. Presumably there's going to be a maximum around here. Here's the value 1. So let's just differentiate. So here, let's work that maximum out. Divide dx y dashed is equal to, now it's a product, so it's u div dx plus v ln x times du dx, and this is to the minus 1, isn't it? So minus 1 comes up to be with the 3, and it's x to the minus 2, so we write x squared underneath. That equals 0. There's a 3 and a 1 over x squared common, so that implies 1 over x squared times 3 outside a bracket, and we've got a 1 here and a minus ln x equals 0. So that tells us that ln x is 1, log x is 1. This is log e, so the e, to undo the log, the e flips, the base number, the e flips down and hits the 1 in the air, and that's how you undo a log. So it's e to the power 1. So this value here is e, and the value here, the high point, is going to be 3 over e, log of e is 1, so it's 3 over e, just bigger than 1. So that looks like what we've got, so let's confirm that with our sketch then. We want 3 over x ln x, so 3 divided by x times log of x. Let's have a look at that. Log x. Natural logarithm. Yeah, it is a logarithm, which is what we wanted. Maybe we'll type ln x. 3 over x times ln x. I'm going to put that in so there's no ambiguity here. And I'm going to do from 0, because it's not defined on the negative axis. And we'll do to 5 to avoid any confusion. And this is what we have. Yeah, our maximum here is at e. And it's not as exaggerated as we thought. It's actually very gently goes back down, doesn't it?